Hello and welcome. In this video we are going to look at how we can back up and restore virtual machines on Linux. This particular video is going to be relatively distribution agnostic, simply because the commands that we're using, as far as I'm aware, are available on most major distributions. I can't necessarily guarantee all, but they're very common commands. It really just depends on, are you using virt-manager and the virsh command to manage your virtual machines. The first thing we're going to want to do when we're backing up a virtual machine is double check its name. Now, if you created the virtual machine and you're deciding you want to back one up, you probably know its name. But if you don't, of course, the virsh command has options that would list the names of the virtual machines that you have. I'm not going to cover them here. I'm making the assumption that if you know you want to back up a virtual machine, you know its name. So what we're going to do is find out where that particular virtual machine stores the file that actually represents the file systems on disk. So for that, we will need the virsh command and dump xml and the name of the virtual machine, in my case, demo2. Now this gets us a fair amount of output. Much of this we're not really concerned with right now. This is all of the information about the virtual machine from an external perspective, from the machine that's managing it. So the hardware that it has access to, how we actually communicate with it. But right now that's not the information we're looking for. But if we scroll back up to the top, there we are. You'll see the name of the virtual machine. You'll see a unique identifier for that virtual machine. You'll find the maximum and current amount of memory that it has allocated to it. You'll find the number of virtual CPUs that it has allocated to it, the architecture of those CPUs, and a little bit below that, under devices, you'll find one or more disk entries. I say one or more because you will find typically a disk that represents a CD-ROM. We're not going to need to back that up, but also some of your virtual machines will actually have more than one disk entry of type disk if they have multiple storage files on disk. Now in this case, I've kept it nice and simple. I'm only using one, but this is a good thing to double check here, especially if you're backing up machines created by other administrators, because potentially they might have created it with multiple disks, and you want to make sure that you're backing up all of them. So we find our disk entries of device type disk, and we find the line source file, because that's the absolute path to the file that represents this virtual machine in storage. It probably is in /var/lib/libvirt/images. I say probably because as far as I'm aware, that is the default location on the major variants of Linux. There's probably one out there that stores it somewhere different, but this is very, very common. Of course, I did say default location. It is also entirely possible that the administrator who first created the machine decided they wanted to store it somewhere else. So, if you've backed it up before and you know where it is, or you created it yourself and you know you put it in the default location, you can rely on it being in /var/lib/libvirt/images. But if you didn't, it's always worthwhile to double check. Now that we know where it is, well, we can back that up. We could potentially just copy the file as is, well, file or files. However, these files will generally be multiple gigabytes in size. If we do an ls-l, now I'm just going to get a listing of that one particular machine because I don't need you seeing all the virtual machines that I happen to have. And we can see this one is approximately 2 gigs in size, which is on the smaller size for a virtual machine. It's a nice, relatively portable size. Sometimes you can find them, if the writing to disk happened very efficiently, you can find them under a gig. Sometimes you will find them tens of gigs. So not exactly the kind of thing that we want to back up on a USB key or SCP over a network to store somewhere. The good news is, these generally compress very nicely. So we're going to sudo gzip. Sudo, of course, to get access to that directory. Gzip because it's a compression tool. So we'll give it the absolute path, var lib, libvirt images, demo2.qcow2. Now, I'm not going to hit enter on this because this is actually a, for lack of a better term, destructive process. When I run this command and create a compressed copy of this file, it then removes the original copy of this file. In many cases, when you're trying to compress a file, that's fine, and that's what you want. You just want a shrunk down version of it that you can transport more easily. But if I'm trying to make a backup of the files that represent a virtual machine, I probably want to leave the original in place. There's a couple of ways that we can do this. You will see some people do this with input redirection, and then of course on the other end they would redirect the output somewhere. The issue with that is sudo does not persist past these redirections. So we would have to switch over to being root using something like sudo-i or sudo su or just su if we happen to know the root password. And maybe we have the capability to do that. Maybe our senior administrator is a little more security conscious and has actually taken away that capability. The good news is we don't actually need that, because there's an option for gzip -c that leaves the original file intact. We still need to do our output redirection somewhere, and this does mean that it needs to be somewhere that doesn't require sudo access. How about I'm going to put mine in /tmp, and I'm going to call it demo2 qcow2.gz. The system isn't really going to care what you happen to call it, but as a general convention, you put gz on a file that you compress with gzip so that you and other administrators will know it was compressed with gzip and can be uncompressed or decompressed with gunzip. So I'm going to hit enter, and this is going to take several minutes. We are compressing a multi-gigabyte file. It is going to take some time. This is a great time to, well, if you already have a coffee, take a few moments. This typically shouldn't be hugely computationally expensive on your machine. This isn't going to be using network traffic, so you can continue doing other things, just not in this terminal. This is also a really good time to mention something that I really should have mentioned before I hit enter on that command, but of course you'll be Well, I already know that this is in the correct state, and you'll be making sure it's in the correct state before you actually start your virtual machine or start backing up your virtual machine. Make sure the virtual machine is off before you start recording it. Start backing it up. Now that was actually somewhat quicker than I expected, potentially due to the fairly nice hardware that I'm working with today. Also the fact that the image file itself was only 2 gigs. So that did complete fairly quickly. Depending on the machine you're working on, I would not have been surprised if it took 10 minutes to back up a 2 gig file. So I thought I had a lot more time to talk and would then have to say, and now I'm going to pause my recording and wait for that to finish. But the machine finished that up for me. So first, I'm just going to double check the original file is still intact. It is. There it is. The exact same size. My last modification date was 2022? I may not be backing up the virtual machine that I think I was. Doesn't matter. Process is the same. I just have to find the right name for the virtual machine I intend to back up. So I've confirmed the original is still in place. I could go and start that machine again and allow myself or others to keep working on it. What I really care about is, did the backup get created? So I will ls-l. I stored it in /tmp demo2. There it is. And it was only 2 gigs to begin with, so it didn't really get compressed that much. It's now down to 1.5 gigs. Generally speaking, the larger it was originally, the more savings you're going to have on compression. I often see 10 or 20 gig files get compressed down to 3 or 4. Be aware it might be larger depending on how much of the actual storage space of that virtual machine you're using. In this case, it ended up as 1.5 gigs. That's still a nicer file to transmit than 2 gigs. So I've made a copy of my image file, but I'm not done yet. You may recall a few minutes ago, we had that XML file that represented the virtual machine itself, the information from the external viewpoint. We need to back that up too. Simple way to do this, if we just go back to our virsh dump XML command, which is apparently not in my history. Oh, probably because I run it with sudo. No, that should still be there. Either way, sudo virsh dump XML. And instead of displaying it to the terminal, I'm just going to redirect it out to temp /temp, that is, /temp demo2.xml. That one's nice and quick because we're just writing out some text data to a file. If we head over to temp and take a look at that file, there's the information from that command. All of the information about the virtual machine name, the unique ID, the operating system it is, the amount of memory allocated to it, the CPUs allocated, the CPU architecture, the storage that we just made a backup of, and where this machine expects to find it, and quite a variety of other information that we're not terribly concerned about at this time, but that Virt Manager is going to be concerned about. once I have this backup, I can now take the two of these and store them somewhere else. It's nice that I have these here. It's nice that I have a backup copy. But what happens if the machine I'm currently working on gets destroyed? Or the hard drive gets corrupted? These backups that I just spent, okay, admittedly only 5 minutes creating, most of it was me talking. If they're on the machine that gets destroyed, they're useless because they're gone too. So we need to back these files up somewhere else. We could transmit them over the network to a network file share like Samba or NFS. We could save them into cloud storage from whatever cloud storage provider you happen to like. We could copy them onto a USB key and just store them somewhere else. They're relatively small. Again, this came out as 1.5 gigs for the image file and I think kilobytes for the XML file. So we could store quite a few of these on a reasonably modern sized USB key. Whichever one we happen to do, it's just important we make a backup copy somewhere separate from this machine, so if something goes horribly wrong, we have a backup copy that we can restore from. How do we restore? Assuming we had removed the virtual machine image, let's make sure I get the right machine. Whether it gets destroyed or corrupted or whatever else, or something goes horribly wrong and we just want to reverse time to a previously saved state, or maybe we're just migrating this to another machine, whatever the case happens to be. That virtual machine is gone. If I try to start it, I'm going to get an error message. It doesn't exist because there's not a file that represents it. The image file is gone. But that's okay. We have a backup. We're capable and responsible administrators. We made a backup of our work. So all we need to do is decompress that backup file that we made and put it to the original location. Now this is one of those times where, unfortunately, because we are needing write access to that folder, we are going to need to become root. Now the command we're going to need is just gunzip, and we'll read in from wherever we have that backup. And we'll write that out to var libvirt images and the name that we want the file to have. In this case, knowing the machine that I'm working with, we already confirmed, if I can type it correctly, demo2.qcow2. Now, this is going to take a couple of minutes, and this time I don't have talking to do, so I am just going to pause this. I didn't even get the opportunity to pause it. My hardware is performing fantastically today. I've been using some hardware that is not mine, that is, let's just say, underperforming, and leave it at that. So we've restored our virtual machine, or we've restored the image file. We also potentially need to restore the the XML file too. Whether this machine got deleted. Sorry, I'll rephrase that. We potentially need to restore the XML. Now that the image file is back in place, I should be able to start that virtual machine. Oh, I was actually getting a different error message than I thought I was earlier. In my case, this particular demo, it's expecting a network that I created that doesn't provide DHCP to be active, and I didn't have it active. I'm just going to pause while I set that up. Give me a moment. Okay, off screen, I just went and I turned my non-DHCP testing network back on. So I'm going to remove that virtual machine image again. And now I'm going to try to start it. And this time it does actually get past the network selection and realizes it cannot access the storage file because it's not there. In this case, we happen to know we just deleted it, but it could just as easily be corrupt and it's not starting, or whatever other reason. So again, I will switch over to Beanroot, or find an administrator who does have the capability to do that. Unzip my backup file into the correct location, leaving the original backup in place so I'm not destroying my backup in this process. I'm going to pause. Okay, once again, that was actually quite quick, but the restoration process is complete, so I'll leave Beanroot because I don't need to stay here, or don't want to stay here any longer than I absolutely need to. And now if I try to start up my virtual machine, it starts. And yes, off screen we could now interact with it, whatever, but it's running again. Now in this case, that worked fine because all that was wrong was the image file. But if somebody had actually destroyed the virtual machine completely, or if we were migrating it to a new machine, that's where we would need that XML file that we also backed up. The demonstration that I just did, the machine already knew all the details because I didn't actually interfere with that XML definition. But off screen, I'm going to turn off that particular virtual machine. I'm just waiting for it to shut down. And I can see in the graph the CPU just went down to very, very low, so it should be shutting off. Okay, I'm going to pause again just to sort this out. Okay, I'm back. It just, for whatever reason, had ignored the original shutdown message, probably because it was still actually booting up. Regardless, I shut it down and I've actually deleted it from disk. If I try to start it again, in this case, this machine doesn't even know what this Demo2 virtual machine is. It has no record of a machine called Demo2. So I could go back into root and restore that backup back into place. But this isn't going to completely fix the matter because, yes, I will have that image file back in place, but the machine still doesn't know about a virtual machine called Demo2. It doesn't know where its storage is. It doesn't know what hardware it has access to. It doesn't know how much RAM and CPU and all that. And that's where the XML file comes in. And that's why we backed it up to whatever offsite location. So for that, we will sudo virsh define, and we'll read in from the XML file that we created. Or that we backed up from. So we'll see domain defined. It now knows about all the same stuff that we had before. That it has whatever amount of RAM that it had, 2 CPU cores. That its storage is in varlib libvirt images demo 2.qcow2. So now if we try to start it, now it works. So what we've looked at in this video is the process of backing up a virtual machine, how we can figure out what files we're actually going to back up, making sure we back up the XML file that represents the virtual machine as well, making sure all of the files that we're backing up, we take them and store them in an offsite location as well. And then we looked at how we can restore a virtual machine from our backups. Whether it's a matter of just unzipping the image file itself because a file got corrupted or deleted, or potentially having to completely redefine a virtual machine from the backed up XML file. With this, you can back up and restore virtual machines, and as long as you're making your backups, you can be confident that your virtual machines are safe. If something horrible happens to them, you have a backup, and you have the capability to restore them. Thank you, and I'll see you in the next video.